All right, so vectors. Vectors in space are denoted by ordered triples with our chevrons. Okay, so if I wanted to, and maybe this would be a good review for you, Eric Spain.
Yeah.
If I wanted to plot -1, 2, 4. Here's X, Y, Z. All right, so -1, 2, 4 would get us to here. So if I'm gonna make my vector, there it is. Which octant is this vector in? Octant number 2. Okay, now I'm not gonna make you plot vectors, okay? I'm gonna make you plot points. We won't worry about plotting vectors, but I wanted to remind you that a vector, oh, Mallory, you said it. What did you say?
Magnitude and direction.
Okay, has magnitude and direction. We're gonna talk about that. We go from origin to the coordinate with an arrow, and we can tell the difference between a coordinate and a vector because of those chevrons. Instead of parentheses, we have the alligators. Okay. All right, so let's remember, what if I know where our vector starts and where it stops? Okay, so here we have vector PQ. Vector P, or point P is 1, 2, 3. I got really creative on that one, didn't I? And point Q is -2, 0, 5. When we write our vector, what order do we need to do the subtraction in? Terminal minus initial. Okay, so vector PQ we're going to take -2 minus 1. We're going to take 0 minus 2. We're going to take 5 minus 3 because we're taking the terminal minus the initial. No, it's not alphabetical. Okay, but I could ask you for the vector QP. Just, he's not talking.
He's talking.
Let me give myself some distance here. All right, now, do you remember when we had the vectors I and J? Okay, well now in 3 dimensions, we have the vectors I, J, and K. Or now I in 3 dimensions is 1, 0, 0. J in 3 dimensions is 0, 1, 0. And now we have vector K. It's our unit vector in the Z direction is the vector 0, 0, 1. Okay, so I'll remind you about linear combination form, where we take our components and we attach them to our unit vectors. Okay, notice how I don't have any commas. It's just three terms that we're adding together. Negative 3i minus 2j plus 2k. Okay, I take these components and I attach them to I, j, and k, and we are adding or subtracting them together. This one can be alphabetically, yes, thank you. All right, so let's remember some things. What does magnitude mean when we are talking about a vector? Length. So if we have the vector v with our two components, then the magnitude of vector v, we took the square root of horizontal component squared plus vertical component squared. And it's based off of the Pythagorean theorem, which is also based off of the distance formula. Ooh, okay. So when we are in 3 dimensions, if we have a vector that has 3 components here, then the magnitude of our vector, we're going to find it the same way. We just have a 3rd dimension. v1 squared plus v2 squared plus that 3rd dimension squared. Grayson, do you need to come sit at this table by yourself? Are you sure? Yeah. Okay. All right, we're gonna find the magnitude of this vector right here. So write it down. So we have the magnitude of v is the square root of -1 squared plus 2 squared plus 2 squared. Okay, and what do we got under the radical?
9.
What's the square root of 9?
3.
So the magnitude of this vector is 3. And that was kind of like a polite way of me saying, like, pay attention and not talk to me. That is unfortunate for Patton. All right, operations with vectors. Would you please write down these 2 vectors? 1, -2, 3 is vector u. Vector v is 0, 5, -2. Write them down. We're going to do some operations with them. Okay, I want to find u minus v. So we are taking 1, -2, 3, and we are subtracting 0, 5, -2. Write down what you think the answer is. Write down what you know. Hank, what do we got? Do you agree with Hank? Good. Now, if I ask you for 5V plus 2U, we need to distribute 5 through V. We need to distribute 2 through U, and then we can add them together. So 5V, I'm going to write as 0, 25, negative 10. 2U, I'm going to write as 2, negative 4, 6. And so now we can add them together to get 2, 21, negative 4. Grayson, bonus question. What octant would this be in? Good. This is an octant 5. All right, let's remember what a unit vector is. What does it mean if we have a unit vector? Vector with magnitude 1. Okay, so if you recall, I asked you to take a vector and find a vector in the same direction with magnitude 1. I will remind you that vectors in the same direction are scalar multiples. Okay, so what we're going to do is we're going to take our vector v and we're going to multiply it by 1 over the magnitude, forcing this vector to have magnitude of 1. Okay, so we're going to take this vector right here, negative 1, 2, 2, and we are going to find a unit vector in the same direction as this guy. Huh. Thank you. Probably something about your schedule next year. Okay, so did we already find the magnitude of this vector? What is it? Okay, so our unit vector in the same direction is going to be 1/3 times the vector. So we have the vector negative 1/3, 2/3, 2/3. I mean, we didn't find like unit matrices, but we did something with a number outside of matrix.
Oh, like with the children?
Matrices was like one of our easier units.
It
Though.
was just that. It was
Tedious.
but
Okay. Don't say. That hurts my ears. All right. Let's remember how to do the dot product. Fun fact, you get to learn 2 different ways to multiply vectors. Tomorrow, I will teach you the cross product. Today, let's remember the dot product. So the dot product is a way for us to multiply vectors and get a scalar. Tomorrow, the cross product, we will multiply vectors to get a vector. So in 2 dimensions, if we have vector u times vector v, then we multiply the horizontal components together, plus we multiply the vertical components together. Do you remember that? You don't have to answer me, okay? So if we have two vectors in 3 dimensions, same thing, people. We are going to take the horizontal components and multiply them, plus the vertical components and multiply them, plus the z components and multiply them. Henry Vogt is running for senior class president. You don't get to vote for Vogt because you are not in the junior class. Yes. Yes. Now this all makes sense. Okay. I'm gonna have Isaac stand up and erase the don't.
What?
Erase the don't, please. If I can reach it, you can reach it.
You need to do.
All right, so the dot product. Let's find the dot product between these two vectors. Write them down so you have the example. Okay, so what we'll do is we'll take -1 times 3, and we'll add it to 2 times 2, and we'll add it to 2 times -1. Eric, what's our dot product? You don't agree, or you didn't do it? I was gonna give you time. -3 plus 4 minus 2, it checks out? Cool. Okay, so tomorrow, speaking of matrices, we actually get to use a matrix to help us with the cross product. You'll like it, I promise. All right, we had a formula to find the angle between vectors. Now, I know we talked about how vectors have magnitude and direction. We haven't really talked about direction. Well, in 3 dimensions, we technically have like 3 different angles. We have an angle between the vector and the x-axis, y-axis, and z-axis. Let's just not even worry about that, okay? So when we talk about direction, there's a lot more to it than just one angle. So we're not going to worry about that, but we are going to worry about the angle in between vectors. And this is where the dot product comes in handy. I will remind you that the angle between 2 vectors, we know that the cosine of theta is the dot product over the product of their magnitudes. So you will need your calculator, and you will need the inverse cosine button of your calculator. Now, if you checked out a calculator, I've checked it back from you, but I have 4 calculators sitting in the dock up there. If anyone needs a calculator during class, we can use one and put it back. Okay. I just wanted to make sure that if anybody owed a fine, I got that in before finals started. So what mode should you be in your calculator? Degree mode. Okay. So here are the 2 angles we are going to find the angle between. So go ahead and write these down: 102 and 310. Okay. So the cosine of theta. Okay, so first we need the dot product. So if we take 1 times 3 plus 0 times 1 plus 2 times 0. What is our dot product? Okay. Now let's find the magnitude of u. If I take the square root of 1 squared plus 0 squared plus 2 squared, we get the square root of 5. If I take the square root of 3 squared plus 1 squared plus 0 squared. Okay. So in our calculator, we need to take the inverse cosine of this fraction. Please remember to either use that fraction key, or if you're not going to use the fraction key, your denominator needs to be in parentheses. Please find me this angle. If you don't have a calculator, I have ones for you to borrow. It's amazing that I say things and people don't listen. Okay. What do we get? 90. So question, what's the cosine of 90 degrees? 0. The cosine of 90 is 0. So what does it mean when our dot product is 0? Okay. If our dot product is 0, then our angle is 90 degrees, which means our vectors are orthogonal. It means perpendicular vectors. It's just a fancy word. Yes.
Is it not 2
I mean, it is, but we're always going to go with the closer angle. So if two vectors are 270 degrees apart, it's probably easier to say that they're 90 degrees apart. Do you see what I'm saying? Like with this formula. Yeah, but yes, you are right. You are right. Okay. All right. Okay, so let me ask you this. If we had 3 coordinates in the XY plane and I asked you if they were collinear, how would you make that decision? Guess? I appreciate your honesty. What should be true about the first point to the second point compared to the second point to the third point? No. If these are on the same line, then their slopes should match, right? Okay. Oh, that's not what I wanted. So let's think about, what if we're in 3 dimensions? And I ask you to determine, do we have 3-dimensional slope? That's what vectors are for. Vectors are what helps us with 3-dimensional slope, okay? So I want to go through how we're gonna do this, okay? If we have 3 points, okay, we can create 2 vectors out of 3 points, right? Okay. If we create 2 vectors that are parallel, Okay, if we have two vectors that share a point and the two vectors are parallel, so parallel means they're going in the same direction or opposite direction. Okay, then our points must be collinear. But if we have three coordinates and our two vectors are not parallel, they're not going in the same or opposite direction, then our points are not going to be collinear. Okay, so our vectors are a way of determining three-dimensional slope, if you will. Okay, how do we know if vectors are parallel? How do we know if they're going in the same or opposite direction?
The angle.
You look at it. They're scalar multiples of each other. If vectors are scalar multiples of each other, then they're going in the same or opposite direction. These two vectors are going in the same direction. These two vectors are going in the opposite direction. Okay, if our vectors are scalar multiples of each other, they are parallel. Okay, so one of the things you're going to have to do, not only in your homework tonight, but on Monday's test, is you are going to be giving three coordinates and you have to prove to me whether they are collinear or not. So please write these down. Okay, now there is one method for doing this problem, but your work could look different than your neighbors because you might create different vectors out of 3 points, but it doesn't matter. No matter what though, we need to create two vectors out of these three coordinates. Okay, so I want to start by making the vector PQ. Okay, and remember we must take terminal minus initial. So let's do that. Terminal minus initial. Terminal minus initial. Terminal minus initial. Okay, now let's make a second vector. What's another vector you want to make? QR sounds great. Okay. Terminal minus initial. It's 4. Terminal minus initial. Terminal minus initial. Okay, so do you notice how if we take PQ and we multiply it by -2, we get QR? Okay. So that means that PQ is parallel to QR. That's what that means. So since PQ is parallel to QR and they share point Q, then P, Q, and R are collinear. What?
Why?
Okay, that's what these are doing. Okay, that's what it's doing.
That's what it works.
So I get what you're trying to do, but I need you to like prove it to me. So I'm gonna ask you to use vectors to do it. Okay, you gotta do your homework, okay? You gotta especially try these problems with the collinear points, okay? If you don't do your homework, you're not gonna remember the formulas, you're not gonna remember the process. Do your homework, okay? Okay, tomorrow is our last lesson.